Morning, dear students. In previous class, we learned about trigonometric chapters, and up to now we are completed 5 units. In this class, we will learn about solution of simultaneous equations using matrices and determinants. And this is the chapter number 12, and it is the last unit of that is the 6th unit of the first sem in the first year. So in earlier classes, we learned about matrix properties and determinants. Now this chapter is we can say as a applications of a matrix. How to use the matrix to solve the equations. That is the main point here. So let us see. Objectives. On completion of this period, you would be able to solve the simultaneous linear equations in 3 unknown by matrix inversion method. Recap. An algebraic equation containing the first degree polynomial is called linear equation. So you can say that is a simple equation or linear equation which the degree is 1. And next point, a linear equation is an algebraic equation in which each term is either a constant or the product of a constant terms, that is terms not times the first power of a variable. These equations are called linear because they represent straight line in Cartesian coordinates. What is the standard form of a linear equation in the two variables? The answer is ax plus by equals to c, where a, b, c are constants. If the constant c in the right hand side of the linear equation ax plus by equals to c is 0, then it is called a homogeneous linear equation. Otherwise, it is called a non-homogeneous linear equation. A linear equation can involve more than two variables. The general linear equation in n variables is a1x1 plus a2x2 plus a3 into x3 up to so on plus an into xn that equals to b. In this form, a1, a2 up to an are the coefficients, x1, x2 dash xn are the variables, and b is the constant. Matrix inversion method. Consider the system of simultaneous linear equations in three unknown r. Three unknowns are, that is a1x plus b1y plus c1z equals to d1, and another equation a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equals to d3. These equations can be written as ax equals to b, where a equals to, you can write as a matrix from three equations coefficients, that is a1 b1 c1, and the second row is a2 b2 c2, and third row is a3 b3 c3. So consider this matrix as A, and x equals to another matrix, that is coefficients x, y, z, and variables, and B is the matrix considered as a constant terms of the right sides, that is d1, d2, d3. If det A is not equals to 0, then A inverse exists. If it is equals to 0 means A inverse does not exist. So to solve the equation, first we have to find the determinant of A. Okay. Next step, what is written, see here. On multiplying both sides of 1 by A inverse, we get, in equation 1 here, Ax equals to B. So to that equation 1 here, multiplying with A inverse, then it is becomes A inverse of Ax equals to A inverse into B. Then A inverse into A means I. So I into x equals to A inverse into B. I into x means x equals to A inverse into B. Then we get the value of x, y, z. So here x equals to means x matrix. So A inverse into B. So this is the, we can say, formula for find the variables x, y, z values. So A inverse into B. A means we know the matrix, and A inverse is not given, so we have to find A inverse. We are in previous classes, we already know how to find the A inverse. And after A inverse, we have to multiply with matrix B, then we will get X. So see how to do. Note. Matrix inversion method fails when determinant is A equals to 0. Determinant of A equals to 0. That is, A is a singular matrix. So we already discussed in previous class also, because A inverse formula is 1 by det A into adjoint A. So in the denominator, if it is 0, we cannot define. So that's why inversion method fails. So if det A is 0 means we cannot find the solution for equations by inversion method. Next, here one question is given. See example 1 or problem 1. Solve the following equations by matrix inversion method. So three equations are given, that is x plus y plus z equals to 6, comma x minus y plus z equals to 2, comma 2x plus y minus z equals to 1. So three equations are given, and we have to solve that equations by matrix inversion method. So let us see the solution. The given equations can be written in the matrix form as ax equals to b, that is a into x equals to b, and we can write where a equals to, so take the coefficients of x, y, z from each equation. The first equation, if you took, write in the first row, and second equation's coefficients write in the second row, like that. So a equals to, we can write 1 1 1, and second row we write 1 minus 1 1, and third we write 2 1 minus 1. So this is a matrix A. Next B, the right side constant terms, take 6 2 1. So this is a column matrix, we can say. Next, x equals to the coefficients x, y, z, this is also write as a column matrix. Next, first we have to test whether it is exists or not. So find the det A, and it is useful for find the A inverse. If it is not 0 means A inverse exists. If it is 0, then inversion method is not comes here. Not we are not get from the inversion method. So let us see det A equals to, so det means put two parallel lines and take the matrix elements of the A, that is 1 1 1 1 minus 1 1 2 1 minus 1. We already know in previous classes. Okay, here expanding with first row, there is not given any information, means generally we can assume it is expanding by R1. So see how to find the determinant. First write the element of the first row of the first, and so eliminate the row and column where the first element is intersected with row and column. The remaining elements are 4, so that is minus 1 1 1 minus 1. Then it's determinant, that is AD minus BC, that is minus 1 into minus 1 1 minus BC means 1 into 1 1. So see here 1 into in bracket 1 minus 1. And next come to the second element. When second element we are coming means we have to take minus, because to simply we say first element is positive and second minus and third positive. See, you recall, I already told you. So one rule, that is minus 1 whole power I plus j. So based on that the plus or minus comes. So or simply we can say first one is plus and the side of the another element is negative and another positive, like that we can write. So expanding the determinant of A by first row is, so in the second element minus 1 into where second element is intersected with row and column. After that, removing, we have four elements, that is 1 1 2 minus 1, and its four elements determinant is AD minus BC, that is minus 1 minus 2, so kept in a bracket, and we simply say minor and cofactor, that is the here plus 1 into again AD minus BC, 1 minus of minus 2 into minus 1 minus 2, so plus 2. So after multiplying this, we get 0 plus 3 plus 3, that equals to 6. So it is not equals to 0. That means A inverse exists. Next point. The matrix formed by the cofactors of the elements of A is cofactors of elements of A. See here. After finding the determinant of A, we have to find the adjoint A. So how the adjoint A formed? First we have to find the cofactors of the elements of A. Then if we transpose that cofactors matrix, then we get adjoint A. And in previous class we knew the how to find the adjoint A. So see here, cofactors of elements of A. Each element we can write the cofactor. So cofactor means minus 1 whole power I plus j into minor. So or simply we can say first element is positive and its side element is negative, and again its side element is positive. So opposite sign is they have. So see here, first one is plus, and first element of the minor is, that is we have to take the row and column where first element is intersected and eliminate. After that we have four elements, that is minus 1 1 1 minus 1, and its four elements determinant is 1 minus 1, simply we can say AD minus BC. So like that each and every element's cofactor we have to find. So first element cofactor is 0, and come to the second element of the first row. So second element means first take the minus symbol, so minus of, and after eliminating the second element where it is intersected with row and column, so first row and second column elements will be eliminated, and remaining four elements 1 1 2 minus 1 and its determinant we have to write here. So minus 1 minus 2, so that is minus 3, minus of minus plus 3, like that. Now come to the third element of the first row. So third means first one is positive, second one is negative, and third one is again positive. So plus, if you write plus or you are not writing plus, no problem, because it is applied as a plus. So third element to minor is 1 minus of minus plus 2, so that is 3. Now we will find the second row of the cofactors. So second row means already in first row first element is positive, so and next of the element is obviously negative, so minus half, and second row and first column we have to eliminate. So remaining four elements determinant is minus 1 minus 1, that is minus 2, minus of minus plus 2. So in the second row first element cofactor is 2. Now come to the second element of the second row, so positive, and after deleting row and column, that is second row second column, then we have four elements and its determinant is minus 3, so here minus 3 written. And come to the next element, so that is negative again, so negative, and it's minor, that is 1 minus 2, so minus half minus 1 means 1. So like, now come to the third element. So in the first column, first one is positive and second one is negative and third one is again positive. So in the third row, first element is positive and its minor is 1 minus half minus plus 1, so 2, and again element of 1, so minus. Minus, here minus is not printed, we have to write minus of, again we have to write its minor, so 1 minus 1, 0. So 0 means that way are not kept minus, but minus 0 is equals to 0, so 0 here we taken. Next, last element, that is plus of. Last element means third row, third column elements we have to remove, and after remaining that 4 elements, determinant is minus 1 minus 1, that is minus 2. So see here, cofactors of elements of A is 0 3 3 2 minus 3 1 2 0 minus 2, and its a transpose is called adjoint A. So transpose of cofactor matrix equals to, see here, the cofactor matrix is written and whole transpose is also written, that is whole transpose. Next, row is converted as a column. Transposing means change row into column, so each and every row is changed as a column, that is 0 3 3 2 minus 3 1 2 0 minus 2. So after interchanging, then we should not write power t or transpose because we are already converted here. So this is the adjoint A. So up to now we found det A and adjoint A. Now come to the formula A inverse. So that Q is don't consider, it is wrongly printed. A inverse equals to adjoint A by det A. So therefore A inverse equals to 1 by det A means 6 and adjoint A means the matrix 0 2 2 3 minus 3 0 3 1 minus 2. Next, up to A inverse we already know in previous class. Till I explained you once again. So this is we are already know. Now the new point is from here. See, now finally we have to find x, y, z. So now x equals to A inverse into B. So A inverse we know, that is 1 by 6 into 0 2 2 3 minus 3 0 3 1 minus 2, and into B. B matrix is at the beginning we are taken, that is 6 2 1. So here 1 by 6 is kept as it is and two matrices are multiplied. How we multiply? Row versus column. So see, first row with first column, that is 0 into 6 0, 2 into 2 4, plus 2 into 1 2, so 0 plus 4 plus 2, that means 6. So write first element as a 6, and to write in the second column there is no second column, so only with first row with first column only one element is we can frame. and come to second row versus first column, because in second matrix only one column is there, so only one element is there, comes with each row of the first matrix. Second row means we have to write in the second row after product. So second row versus first column we can write after multiplying 12. See how 12 comes. 3 into 6, 18, minus 3 into 2, minus 6, plus 0 into 1, 0. So 18 minus 6 means 12. Next, third row versus first column. See, the two matrix product is coming only as a column matrix, because to write another column there is no another column in second matrix. So we already know how to product, and after product how its order comes, order, or we can say okay, order 2 by 2, 3 by 3, like that. So here 3 by 3 and 3 by 1. So 3 by 3 and 3 by 1, we are getting 3 by 1. Let us see the third row versus first column. 3 into 6, 18, plus 1 into 2, 2, minus 2 into 1, minus 2. So plus 2 minus 2 cancel, 18 is there. So 18 wrote. Next here outside we have 1 by 6. So we are taking inside. That means we are multiplying with each element. So 6 by 6, 1. 12 by 6, 2. 18 by 6, 3. That is 1, 2, 3. Then therefore x equals to 1, y equals to 2, z equals to 3. This is the solution. Next question. And one more thing is, we can check whether our solution is correct or not, our answers. Simply you can substitute this x, y, z in any equation of the question. You will get the right side answer. So that means the equation is fulfilled, satisfied. Next, see another question, another example. Second one. Solve x plus 2y plus 3z equals to 14. 2x minus 3y plus 4z equals to 8. 3x plus 5y minus 7z equals to minus 8. Solution. Let A equals to matrix 1, 2, 3, 2 minus 3, 4, 3, 5 minus 7. Same in the previous example, how we will wrote like that here taken. Same. X equals to xyz matrix and B equals to 14, 8 minus 8. Cofactors of elements of A, that is first one is positive, and I already explained you how to find the cofactors of the elements. So symbol into its minor, simply we can say. So first one is positive and its minor is 21 minus 20. And come to the second element. So second element contains negative symbol, so minus kept, and in bracket we are written its minor. So minus 14 minus 12. And come to the third element, positive, and its minor is 10 minus half minus plus 9. Now come to the second row, minus. So it's above element is positive, means it's below is negative. So minus half, minus 14, minus 15, and again its side element is positive. So its minor is minus 7, minus 9, and 4 element 4. So it's minus half, it has minus, and it's minor. So 5 minus 6, and third row, first element is positive, and 8 plus 9, and second element is minus half, 4 minus 6, and last element is positive, and its minor is minus 3, minus 4. So next, that equals to 21 minus 20 means 1, minus 14 minus 12 minus 26, minus into minus plus 26, 10 plus 9, 19, minus 14 minus 15 is minus 29, minus half minus plus 29, minus 7 minus 9 minus 16, 5 minus 6 minus 1, and minus half minus 1, 1, 8 plus 9, 17, 4 minus 6 minus 2, minus half minus plus 2, minus 3 minus 4 minus 7, adjoint A. If we transpose cofactor matrix, then it is like this: 1, 26, 19, 29, minus 16, 1, 17, 2, minus 7. So we are changed rows as a columns, and it is called adjoint A. Then see the det A, expanding by any row of the matrix. Here generally there is not mentioned, means first row. So we know how to find the det A. So element and its cofactors. So first row is it is like here we get 1 of 1 plus 2 into 26 plus 3 into 90, that is equals to 110. That is not equals to 0. Since A is non-singular, A inverse exists. So not equal to 0 means non-singular. A inverse equals to adjoint A by det A, that equals to 1 by 110 into adjoint A means 1, 29, 17, 26 minus 16 to 19, 1 minus 7. By matrix inverse method, X equals to A inverse into D. So 1 by 110 into 1, 29, 17, 26 minus 16 to 19, 1 minus 7. So this is A inverse, and D means, in beginning we wrote a B. So B here written as a D. So don't confuse. B, D are same here. So here printing is a D. So you can change either B as a D or D as a B, no problem. So 14, 8 minus 8. Generally cofactor matrix is indicated as a B. That's why here taken D. Okay, right. Next, after multiplying we get, so we know how to multiply row versus column. Only one column is there, means in the second matrix. After production also only one column comes. but 3 rows, because in the first matrix 3 rows is there and 3 columns also there. So after multiplying we get 110, 220, 330, and if we multiply with 1 by 110, then we get 1, 2, 3. So x means x, y, z. So if we equate the matrix, then we get x equals to 1, y equals to 2, z equals to 3 is the solution. Previous exam questions. Using matrix inverse method, solve x plus y plus z equals to 6, x minus y plus z equals to 2, 2x plus y minus z equals to 1. Second, using matrix inverse method, solve x plus 2y plus 3z equals to 6, 3x minus 2y plus z equals to 2, 4x plus 2y plus z equals to 7. Summary. We have discussed about solution of linear equations in 3 unknowns by matrix inverse method. Wait. First one, the linear equation form from the following is, which equation we can say linear equation? So answer is C, that is 3x minus y equals to 5, because first equation is having second degree and B also second degree because x into y. So it is also second degree. The C is the linear equation. Next, second question. Matrix inversion method is not applicable when see A delta A equals to 0, because in inverse matrix the formula is adjoint A by delta A. If it is 0 means denominator is 0 means we cannot define. That's why the method is not applicable. Next, assignment. Solve the following equations by matrix inverse method. First one, x plus y minus z equals to 3. 2x plus 3y plus z equals to 10. 3x minus y minus 7z equals to 1. Second question. 2x minus y plus z equals to 4. X plus y plus z equals to 1. X minus 3y minus 2z equals to 2. Third, 2x minus y plus 3z equals to 9. X plus y plus z equals to 6. X minus y plus z equals to 2. So here assignment, consider, or in assignment 3 questions are given and you have to do from exercise also. And in the exercise you can see example problems also, and to before going to do the exercise problems, first understand the example problems. And in PPT also we are explained. So very simple method. First thing is x equals to A inverse into B. A inverse means adjoint A by det A. Adjoint A means cofactors transpose. Det A means expanding by R1 element into cofactor, like that. So B means RD, x equals to A inverse into B RD we can say. So right side constant terms, if we framed in a matrix, column matrix, that is BRD. So, and one more thing is we can check our answer by substituting in equations. In any equation, if it satisfies, that means our solution is correct, our answers are correct. Otherwise, if it is not satisfied, means we are made a mistake in a plus minus or product or division. So by doing simplification we are very careful, especially positive comes or negative comes, or the sign is very important. And if you don't know how to add, how to subtract the positive, negative, or with product, like any type, first you have to know that basics. And if you have any doubts how to add the fractions, how to add the different signs or subtract, if you don't know, you can ask me, or you can ask your friends, those who know perfectly, because this small basics very important. The remaining is very easy. So in this method, in the examination one question may comes. So totally we have 3 methods to solve the equations using matrix methods. So first one is inversion method, second one is Cramer's rule, third one is Gauss-Jordan method. So on 3 methods we cannot say which method comes in the exams. If we know 3 methods, then there is nothing to worry, because we can easily happily get high marks, because this is a long question, because to simplify it takes time, and it takes some space also, or 2 pages or more than 1 page. So but problem is very simple. If you know how to do which formula used, then the simplification, if you know small operations, adding, subtracting, whether they are minor negative signs or positive signs or mixed, whatever it may be, so these small operations you should thoroughly know. without doubts. If you are facing any difficulties, you can ask me, mail me, or ask your friends. And one more thing, open the PPT in device and first write the notes and then see the video and listen the video, because in video sometimes screen clarity may miss, the letters may miss it or printed sometimes wrongly. So in the textbook also example problems are there, so see the textbook also. And before watching the video, first see the PPT. Every video is based on PPT, this each and every video. So PPT is also available separately, so I can mail you, send you on WhatsApp or mail, email, whatever it may be. If video is visible clear, then no problem. Otherwise, my advice is open the PPT. It is very less data, only PPTs contains very less data occupies, that is less than 1 MB or maximum to 3 MB. Whether the video is takes some much data. So maximum you can understand by seeing PPT, and if you watch video then you can completely understand the concept or topic or PPT or lesson. And till you have any doubts you can ask me, but you have to complete the fair notes. In fair notes, exercise problems should be there, each and every, and order should be there. And, one by one you have to complete. First write in the rough notes, then come to fair notes and maintain neatly. And after completion, then show me. I will see your fair notes. And if your friends have any doubts, you try to clarify their doubts. If you are not able to clarify, then tell them, send me or ask me, I will explain them. So but all of you should complete your fair notes and practice the problems. So I hope you got my point. And do all the problems of exercise, so you can do easily. So try and complete it. Thank you. Have a nice day.